Hello my dear students, first of all I welcome you all for SVK tutorials. In this session I am going to discuss the model question paper 2 of 4th semester subject complex analysis, probability and statistical methods. Subject code is 18MAT41. Moving with module 1, number 1A is given as follows. Show that W equal to f of z which is equal to log z is analytic using CR equation. So given f of z, you are required to show that it will verify CR equation and hence shown that it is analytic function. Consider W equal to log z. As it is a log function, we can't apply loss of logarithm for log of a plus b. So I will go with the substitution for z as r e power I theta and W is u plus iv. So after that substitution, u plus iv is equal to log of r e power I theta. By applying loss of logarithm for this, we can write that as log r plus log e power I theta. Log e power I theta to the base e is nothing but just I theta. So you are left out with u plus iv as what? Log r plus I theta. So equating real part and imaginary part, here u is equal to log r and v is equal to theta. So now differentiating u with respect to r and theta partially. While differentiating with respect to r, theta will be treated as constant as there is no term called theta in u. So derivative of log r with respect to r is 1 over r. Derivative of log r with respect to theta partially is 0. There is no term called theta. So differentiation of v with respect to r partially is 0. V with respect to theta is equal to 1. So now then we are going to find ur is equal to 1 over r into v theta. We will verify that ur is equal to 1 over r into v theta and vr is equal to minus 1 over r into u theta. Definitely these two are equal. Hence the equations called CR equation is verified. We can conclude that the given function is analytic. Next, derive CR equation in polar form. So already I have derived this polar form, CR equation of polar form in the previous video. If you are interested, you can kindly go through that derivation. Question number 1C. Find the analytic function f of z is equal to u plus iv given that u plus v is equal to x plus y plus e power x times of cos y plus sin y. So consider the given problem and differentiate u with respect to x and with respect to y partially. We are going to get equation 1 with respect to x. We are going to get equation 2 if we differentiate partially with respect to y. So while differentiating with respect to x, you should know that y will be treated as constant. That's why this term is 0. Here derivative of x is 1. E power x derivative is e power x itself. This whole term is constant. Similarly with respect to y, 0 plus 1 plus e power x is constant. Derivative of cos y is minus sin y plus derivative of sin y is cos y. But as the given function is analytic function, CR equation satisfies. Ux is equal to Vy and Vx is equal to minus Uy. Substituting these two in equation 1 and 2, we are going to get equation 2 as Ux minus Uy is equal to 1 plus e power x cos y plus e power x sin y. Yeah, equation, this is what equation 1 and this is equation 2. Make this changes here. This is equation 1, this is equation 2. In equation 2, Vy is replaced by Ux. Vy is nothing but Ux. In first equation, Vx is nothing but minus Uy. That is what we have done and I have named that as equation 3 and 4. Now I am going to solve these two equations 3 and 4. Once if I adding 3 and 4, I am going to get Ux as 1 plus e power x cos y. So directly you can substitute this Ux value in equation 1. We are going to get, I have given alternate method also, you can substitute that in equation 4. In equation 1 I have substituted and I will get Vx as e power x sin y. Then f dash of z is defined as ux plus ivx. Substitute that ux value and vx value. So taking e power x common and substituting x equal to z and y equal to 0, we get f dash of z as 1 plus e power z. Then integrating on both the sides with respect to z, f of z is equal to integral of 1 plus e power z dz. Integral of 1 is z and integral of e power z is e power z plus c is the required solution for the given function. Going with the alternate option, show that real and imaginary part of an analytic function are harmonic. Means you are required to show that uxx plus uyy is equal to 0 and vxx plus vyy is equal to 0. So to prove that, I am going to consider f of z as u is a function of xy plus I into v is a function of xy, be analytic function. Since f of z is analytic, it will satisfy CR equation. Ux is equal to vy, I will name that as equation 1. Vx equal to minus uy, I will name that as equation 2. I am going to differentiate equation 1 with respect to x and 2 with respect to y partially. We get del square as already it has been differentiated. So if you differentiate once again, you are going to get higher order derivative. Del square u by del x square, which is equal to del square v by del x del y, as I am differentiating with respect to x. Similarly, we are going to get, if you differentiate equation 2 with respect to y, I am going to get del square v by del y del x is equal to minus del square u by del y square. Since del square v by del x del y is equal to del square v by del y del x, as we know that mixed partial derivatives are equal, so we can equate those two. Then I am going to get the value called del square u by del x square plus del square u by del y square is equal to 0. Therefore, I can say that u is harmonic. Similarly, again differentiate equation 1 with respect to y. Again differentiate equation 1 with respect to y and 2 with respect to x partially. We are going to get del square u by del y del x is equal to del square v by del y square and del square v by del x square is equal to minus del square u by del x del y. Since the mixed partial derivatives are equal, we can equate that and we are going to get del square v by del y square plus del square v by del x square is equal to 0. So that is nothing but v is harmonic. Thus, we have proved that the real and imaginary parts of an analytic function are harmonic. Going with question number 2b, if f of z is a regular function of z, show that del by del x of modulus of f of z whole square plus del by del y of modulus of f of z whole square is equal to modulus of f dash of z whole square. Consider the given function f of x as an analytic function. Then f of z is defined as u plus iv. Taking modulus of f of z, we are going to get square root of u square plus v square. Then I will define that as psi. Psi is equal to modulus of f of z, which is nothing but square root of u square plus v square. Simultaneously, I will find out derivative of f of z, that is f dash of z is ux plus ivx. Modulus of f dash of z is square root of ux square plus vx square. Differentiating partially with psi with respect to x and y, I am going to get del psi by del x is equal to partial derivative of root x is 1 over 2 root x, as same as like that. We are going to differentiate square root of 1 over square root of u square plus v square as 1 by 2 root of u square plus v square into differentiation of u square is 2u ux plus derivative of v square is 2v vx. 2 get cancelled, then simplifying that we are going to get equation 1. Similarly, we can write del psi by del y as u uy plus v vy whole divided by square root of u square plus v square. Name that as equation 2. Now squaring and adding equation 1 and 2. Squaring and adding equation 1 and 2. You just square both the side and add on left hand side and right hand side. we are going to get del psi by del x whole square plus del psi by del y whole square is equal to, as we squaring, root get cancelled, the denominator is common term, so I have taken LCM, u square plus v square, the numerator is ux plus vvx whole square plus uuy plus vvy the whole square. So expanding this, I am going to get this equation, and adopting the CR equation here in this expression, I am going to get this expression. Then these two terms get cancelled after substitution of CR equation. These two terms get cancelled. We are going to get a common term called ux square plus vx square times of u square plus v square whole divided by u square plus v square. Both the term get cancelled. We are left out with ux square plus vx square. That is what your modulus of f dash of z whole square. Hence it is proved. If w equal to f of z is equal to phi of x comma y plus I into psi of x comma y represents the complex potential of an electronic field where psi is equal to x square minus y square plus x by x square plus y square. Find f of z and hence determine phi. So consider the given function psi, differentiate psi partially with respect to x and y. This is what I have got. While differentiating this term, you should apply a quotient rule, as we have x by x square plus y square while differentiating with respect to x. So simplifying that, we got psi x like this and psi y is this one. Consider f dash of z as phi x plus I psi x, but according to CR equation, phi x is equal to psi y. So substituting that, f dash of z is equal to psi y plus I psi x. Put x equal to z and y equal to 0 simultaneously. So therefore we get f dash of z as this expression by substituting x equal to z and y equal to 0. Correspondingly, I am substituting that value. So which is equal to I times of 2z minus 1 over z square. So integrating on both the side, f of z is equal to I times of z square plus 1 by z plus c. To find phi, now I am going to substitute the value of z as x plus iy, f of z as phi plus I psi. So therefore, to get phi value, equating the real part and imaginary part, we are going to equate the real part and imaginary part. To equate that, I am going to separate real part and imaginary part in the right hand side. So therefore, after substitution, x plus iy the whole square plus 1 over x plus iy, I got this expression. Then simplifying further and separating the real part, this is what real part and this is what imaginary part. So this is nothing but called phi. Hence we have find out the electric potential called phi. ನನಗೆ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿದೆ ನಮ್ಮ ಹುಡುಗರಿಗೆ ಇಂಥ ಕಷ್ಟದ ಪ್ರಾಬ್ಲಮ್ ಇಷ್ಟ ಆಗಲ್ಲ ಅಂತ, ಬಟ್ ವಿಧಿ ಇಲ್ಲ. VTU ಏನಾದ್ರು ಕೊಟ್ರೆ ಈ ಕ್ವಶನ್ ಬೇಜಾರು ಮಾಡ್ಕೋಬೇಡಿ, ಕೊಡ್ಲಿಲ್ಲ ಅಂದ್ರೆ ತುಂಬಾ ಖುಷಿಯಾಗಿದೆ. Moving on to module 2, state and prove Cauchy's integral formula. The proof is already proved. You can refer my previous video. ಇಲ್ಲೂ ಬೇಜಾರು ಮಾಡ್ಕೋಬೇಡಿ ಯಾರುವೆ, ನಾನು ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋ ನೋಡಿ ಅಂತ. ಸೊ ಪದೇ ಅದೇ ಕ್ವಶನ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಕ್ಕಾಗಲ್ಲ, ಆಲ್ರೆಡಿ ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಆ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋ ನೋಡಿದ್ರೆ ಸಾಕು ನಿಮ್ಗೆ. ಸೊ ಇದ್ರ ಕಂಟೆಂಟ್ ಅಲ್ಲಿದೆ, ಹಾಗಾಗಿ ನಿಮ್ಗೆಲ್ಲ ಅರ್ಥ ಆಗುತ್ತೆ. ಸೊ ಜಸ್ಟ್ ಅಬ್ಸರ್ವ್ ದಿ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಸ್. Discuss the transformation w equal to f of z, which is equal to e power z with respect to the lines parallel to coordinate axis in z plane, which is an important problem. W equal to e power z, consider put z equal to x plus iy and w equal to r e power I phi. So therefore we got r e power I phi is equal to e power x plus iy. By applying laws of indices, I am going to get e power x into e power I y. Then equating the real part and imaginary part, r is equal to e power x and here phi is equal to y. So if I go with two cases, I am going to discuss two cases. They are asking with coordinate axis parallel to the coordinate axis, means parallel to y axis and parallel to x axis. So if x equal to c is the line parallel to y axis, then modulus of w or f of z will be equal to e power c. Modulus of w will be equal to e power c. As there is no term called y, just put x equal to c. We are going to get, if you substitute x equal to c here, we are going to get e power c, which is a circle under w plane. So therefore, under this transformation, the lines parallel to y axis are mapped onto a circle in w plane. This is what the pictorial representation. Now consider case 2. If y equal to d, that implies phi equal to d. Since phi value is equal to y, just substitute the value of y as d. We are going to get phi equal to d. So the lines parallel to x axis are mapped onto a straight line which passes through the origin. So under this transformation, the line parallel to x axis are mapped onto a straight line passing through origin. This is the pictorial representation. Then moving on with bilinear transformation problem. So it has been already explained to you neatly. Here z2 value is infinity. Z2 value is infinity. So divide by z2. Divide by z2 in this term and in this term. I am going to get 0 minus 1 and here 0 minus 1. Cancel those two terms. I will left out with I by z is equal to w plus 1 by w minus 1 times of minus of I plus 1 divided by minus I plus 1. Multiply and divide by the conjugate of minus I plus 1 is I plus 1. Multiply and divide by I plus 1. I am going to get, after multiplying and dividing by I plus 1, I am going to get this value. Then expanding this, I am going to get 2I by 2. 2 get cancelled. Therefore, I minus I is left out. So multiply by minus sign on both the side and cross multiplying. We are going to get minus w plus 1 is equal to wz plus z. Taking w common, you are left out with w as equal to 1 minus z divided by 1 plus z is the required BLT. As they have asked to find fixed point, or also called as invariant points, replace w by z. We are going to get the quadratic equation called as z square plus 2z minus 1 is equal to 0. So solving that, we are going to get z equal to minus 1 plus or minus root 2 are the fixed points. Moving on with optional question. Verify Cauchy's theorem for integral over region 1 by z dz, where C is the triangle with the vertices 1, 2, 3, 2 and 1, 4. My dear students, ನನಗೆ ಚೆನ್ನಾಗಿ ಗೊತ್ತು ನೀವು ಯಾರು ಈ ಪ್ರಾಬ್ಲಮ್ ನ ಸಾಲ್ವ್ ಮಾಡಲ್ಲ, ಯಾಕೆಂದ್ರೆ ಮೋರ್ ಓವರ್ ಇಟ್ ಇಸ್ ಅನ್ ಇಂಟಿಗ್ರೇಷನ್ ಪ್ರಾಬ್ಲಮ್. ಹಾಗಾಗಿ ನಾನು ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಐ ಆಮ್ ಕ್ವಿಟ್ಟಿಂಗ್ ದಿಸ್ explanation and also I feel that they will not ask in your examination this type of problems. There is a chance of asking a square or a rectangle problem or a line problem. There is no chance of asking a triangle problem. So I am going to quit this explanation. ನಿಮ್ಗೆ ಏನಾದ್ರೂ ಯಾರಿಗಾದ್ರೂ ಆಸಕ್ತಿ ಇದ್ರೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ kindly put a private comment for me, so I will give an explanation for that. Moving on to next problem. 4b. Evaluate integral over region C dz by z square minus 4 over the curve C. Modulus of z plus 2 is equal to 1. Modulus of z plus 2 equal to 1 means what? It is a circle with center as minus 2, 0 and radius 1. Now the problem is of the form f of z by z minus a. Now consider 1 over z square minus 4. So factorizing this, I am going to get 1 by z minus 2 into z plus 2. Now resolve this by partial fraction. I am going to find out the value of a and b. I got the value of a as 1 by 4, b as minus 1 by 4. Substituting the values of a and b in equation star, and integrating on both the side with respect to z or region C. Here f of z is 1 here, so nothing to worry about f of z. So therefore multiplying and integrating with respect to z, I got this equation 1. Since the given curve C is what? It is a circle with center as minus 2 comma 0 and radius 1. F of z is 1. To find out whether this point lies inside the circle or not, we are going to consider a point called A as minus 2 comma 0, the circle, and P1 is the point from this value 2 comma 0. P2 is the point from this value minus 2 comma 0. By applying distance formula, we are going to get AP1 is equal to 4, which is greater than 1, which lies outside C. Therefore, this integral value is what? 0. By Cauchy theorem, we can say that this integral value is 0. So, by applying a distance formula, AP2 is equal to 0, which is less than 1. So, which lies inside C. So, therefore, by Cauchy theorem, we are going to apply Cauchy theorem. 0 minus 1 by 4 times of 2 pi I f of minus 2. 2 pi I f of minus 2. So, by simplifying, we are going to get the integral value as minus pi I divided by 2. Moving on to question number 4C, it is an bilinear transformation. I have explained this similar problem in my previous video. Go through that video. Moving on to module 3, the probability distribution of a random variable x is given by the following table. Find the value of k, probability of x less than or equal to 1, probability of x lies between 0 and 3 is not included. So therefore we should exclude 3 here. We should just find out probability of 0, probability of 1, probability of 2. So to find the value of k, as the given function is PDF, it should satisfy probability of xi should be greater than or equal to 0 for all k greater than or equal to 0, and summation p of xi should be equal to 1. So adding all the values of k, that is adding all the probabilities of x, we are going to get k value as 1 over 32. Substituting this in the table, we got this new values of table of content. So to find probability of x less than or equal to 1, just find out probability of 0 plus probability of 1. We got the answer as 3 by 16 by simplification. Now to find probability of 0 less than or equal to x less than 3. So which is nothing but p of 0 plus p of 1 plus p of 2, which is equal to 1 by 2 is the required answer for the given problem. Moving on to question number 5b. In a certain city, the duration of shower is exponentially distributed with mean 5 minutes. What is the probability that a shower will last for 10 minutes or more, less than 10 minutes, between 10 to 12 minutes? So in the given problem itself, they have given the hint. The problem is of the form exponential distribution. So as we know that by the definition of exponential distribution, we can write f of x as alpha e power minus alpha x for x positive and 0 otherwise. So given mu, mean, that is mean is given 5, mu is equal to 1 over alpha, therefore alpha is equal to 1 over mu, which is equal to 1 by 5. Alpha is what? 1 by 5. Therefore f of x is defined as 1 over 5 e power minus x by 5. This is as same as previous model question paper. Just the problem is different. Probability of x greater than or equal to 10 we require to find out. 10 to infinity. Integration is same. So substitute that integral value. We are going to get 0.1353. Similarly, x less than 10, 0 to 10 we require to find out. So we got the answer as 0.8647. 10 to 12 is considered as integral 10 to 12. So integration is same. So therefore I got the answer as 0.0446. Moving on to question number 5c. The marks of 1000 students in an examination follow a normal distribution. So it is a problem on normal distribution with mean mu equal to 70, sigma equal to 5. Find the number of students whose marks will be less than p of x less than 65, p of x greater than 75, p of x lies between 65 and 75. So write down the given values: mu equal to 70, sigma equal to 5, and capital N equal to 1000. By standard normal variant, we have z equal to x minus mu by sigma. Substituting mu and sigma value, I will get z. Then if x equal to 65, therefore I am going to get z value as minus 1. Probability of x less than 65 becomes probability of z less than minus 1, which is as symmetric about z equal to 0. We can write that as probability of z greater than 1. So therefore 0.5 minus this distance, 0.5 minus this distance, that is nothing but phi of 1. So we are going to get the value as 0.1587. In the previous video I have explained how to find out the normal distribution value if they have not given the specified value of normal variant. Therefore the number of students scoring less than 65 marks is 1000 times of this value. We are going to get 159. Similarly, if x equal to 75, we are going to get z equal to 1. So probability of x greater than 75 is equal to probability of z greater than 1, which is equal to 0.5 minus phi of 1, which is equal to 0.1587. So multiplying by 1000, we are going to get 159. So between 65 and 75, we are going to get the value as z value as minus 1 and plus 1. So as the value is symmetric about z equal to 0, we can write that as 2 times of probability of 0 to 1. So that is nothing but 2 times of phi of 1. So which is equal to 0.6826. Multiplying this value by 1000, I am going to get the required 683. Moving on to question number 6a. The probability density function PDF for the continuous problem. So here kx square, we require to find the value of k, and x lies between 1 and 2. Probability of x greater than 1. To find the value of k, we have a condition that f of x should be positive for all k positive. Then integral minus infinity to plus infinity f of x dx is equal to 1. As the problem is defined only in the interval minus 3 to 3, so we will define that as integral minus 3 to 3 kx square dx equal to 1. Integrating this, we are going to get the value of k as 1 by 18. Substituting that k value, I have redefined f of x here. Then probability of 1 to 2, definitely 1 to 2 lies between minus 3 and plus 3. Therefore substituting that value and integrating, we are going to get the answer as 7 by 54. Now considering probability of x greater than 1 and differentiating, as they have asked probability of x greater than 1, you should consider 1 to 3, 1 to integral 1 to 3. Integrating this, I am going to get 26 by 54. So moving on to question number 6b. Suppose 300 misprints are randomly distributed throughout a book of 500 pages. Find the probability that a given page contains exactly 3 misprints, less than 3 misprints, 4 or more misprints. So here this problem is on Poisson's distribution. So given, suppose 300 misprints randomly distributed throughout a big book of 500 pages, we are going to get mean value as 300 divided by 500, which is equal to 0.6. This is the way of finding mean value, that is m.6. Then substituting in the formula called general formula of Poisson's distribution, p of x is equal to m power x into e power minus m divided by x factorial. Substituting the value of m 0.6 whole power x into e power minus 0.6 divided by x factorial, and now substituting at x equal to 3, we are going to get this value. At x is less than 3, we are going to get this value. At x is greater than or equal to 4, it is 1 minus probability of x less than or equal to 3, so which is nothing but 0.00838. Moving on to question number 6c. The question number 6c is of IQ problem. This IQ problem I have done separately a video, I have explained in depth, and if you have any doubts in that, you can ask me.